Hello there, Preface. My name is Chris Hancock. I'll be presenting the principle of buoyancy to you today. Now, buoyancy is a scientific principle. It was come up with about 2,400 years ago, give or take, and even though it was invented such a long time ago, it's such a simple, effective idea that we still use it to this day. Because of buoyancy, we'll be able to determine what objects will float in the water, and from that we got boat design, and boats were obviously a very, very big part of human history. And the fascinating thing is that this idea doesn't just apply to boats, it also applies to airplanes, right? Even though one's floating in the water, one's flying through the air, the idea that keeps them up is the same. So, buoyancy was invented by a man called Archimedes, who lived in the year 246 BC. Right, thousands of years ago this man lived, but his ideas, we still use them to this day. So it doesn't really matter when you come up with an idea. If it works, it works. Archimedes was a very, very clever person. He actually invented the screw as well, which is like a nail with grooves on the side, so you twist them in, and that secures it much more, so that fastens something much more securely than just a regular nail. So if you come up with an idea, if it's a great idea, it's just universally a great idea. So the idea behind buoyancy is that if an object is placed in liquid, its weight will push it down, but another force called buoyancy will push it up. If you want to make something that will definitely float on the water, you need to calculate how much water it will displace when you put it in the water, and make it so that the object is the equal weight to that water, right? Because of that, it will float every single time because of this principle. Now, Archimedes was obviously a very, very clever man. He realized this, however, is quite a funny story. He realized this principle of buoyancy when he was about to get in the bathtub, and he got into a very, very full bathtub. What happens when you get into that water? It rises up and it overflows out of the bathtub, and that's how he realized that water. That's how he realized that water gets displaced by things getting put in the water. And from that, he came up with this whole idea of buoyancy. And he was so excited when he got into the bath. He was so excited by this idea. He's just suddenly this flash of brilliance that he had. He actually ran out into the street completely naked, shouting "Eureka!" which means "I have it." But so this idea again was very, very important in ancient times, and we use it to this day with aeroplanes. So some examples of buoyancy is a person floating with a life vest in the water, right? The life vest is filled with air, and so the vest provides the buoyant force to keep a person floating. The vest displaces lots of water, and it creates an upward force that keeps you afloat. Another example is a large ship floating in the ocean, like a large metal ship. It should probably sink to the bottom, but they build them really, really big so that there's lots of air contained inside, and because of and the shape of the hull, the shape of the boat itself, right, is curved to make sure that there's a lot of water displaced, and that creates more upward force, a lot more buoyancy. So there are more examples, but for another one is that helium balloons. Helium is less dense than oxygen, and so a balloon filled with helium will experience extreme upward buoyant force, causing it to rise and rise and rise until it either runs out or it goes all the way up into the atmosphere. And we use this in a lot of design of vehicles. If you want a submarine to go up or down, you have this thing called a ballast tank. You fill it with more water if you want it to go down. You release the water if you want it to go up. And these ideas are also observable in nature, right? A fish has something like a ballast tank in its bladder. If it wants to go down, it releases some gas. If it wants to go up, it builds up gas very, very quickly. So these principles aren't just for machines. They're also observable in nature, which is I find very interesting. So, principle of buoyancy was invented about 2,000 years ago, but it wasn't used until 1903 when the Wright brothers first built an airplane. They were still, even though this was only 100 years ago, they were still building off the ideas of people like Aristotle and Archimedes. So I really like this because it shows that scientists help each other over the generations. They write down their findings and other people use them to build something better, and the next generation builds something better after that. And so generations of scientists help each other come up with the best possible ideas that we enjoy to this day. So buoyancy, it also explains, as I mentioned before, it also explains how planes manage to fly. So to fly a plane, it needs to displace a mass of air down that is equal to its own mass. Every single second it needs to do this, or it won't be able to fly. Planes are effectively, they're floating on a cushion of air that the wings are creating by pushing air downwards. So this is a similar explanation to how boats are floating according to Archimedes' principle of buoyancy. Or also how birds fly. They fly by pushing air downwards, and they have all sorts of things in their biology that helps them with that. Like, for example, their feathers are very much designed to capture as much air as possible, right? A large surface area. And also in their lungs, they have special alveoli that that expand greater and fill in with more air, which allows them obviously to go up and down, or release the air to go down. So there is no real scientific experiment that proves the theory to be correct. When it comes to aviation, it's more of a theory of buoyancy, but no one can really, it's like the theory of evolution. No one can really prove it or disprove it, but it works, so we use it very often. So no one has been able to have a valid scientific argument to disprove it. So there you have it.